Hello, everyone. Let's see. We are giving it a few minutes to get started. If you are here and waiting, I'm just trying to find how I invite another person to be part of this. So give me a moment. I'll be right back. So, hello and welcome. Click twice to maximize video. Hold on. There we go. I don't know why. All right. Welcome to the knitting workshop. I have a co-host, but he seems to have trouble getting into hopping in and the workshop. So we're going to get started. Hello. Give me a moment to send a message to Paul to make sure that he will join us in a little bit. Hello, great to see you. I see we have some people here. We're going to talk a little bit about knitting. Let's see, I keep getting this click twice to maximize video, so I hope you can see me okay. So I'm sitting in the knit lab at Kent State University. You can see we have an industrial knitting machine behind me, and I have some yarn on the other side. And this is where we teach knitting on a regular basis. And where a lot of the hackathon normally takes place. We usually have a lot of people working in here and testing things out and prototyping. And so we don't want to lose the knit component for this year. And so I'm hoping that there will be some involvement still. So I'm going to share my screen and do a little bit of a presentation. So share screen. Hold on, let me get my screen set up in the right spot. And just 1 second. We are all learning a little bit, and it's taking a moment for us to get used to the different technology. So thank you for chit-chatting in the chat while I am getting this set up. It's good to be first out, but it does put you on the spot to when things aren't working right. All right. So let's see. I am going to share my screen with you. There we go. I hope you can see my, I was going to be in my presentation view, but I'm not. We're going to leave it like that for now so you can at least see it. So what I'm going to talk a little bit about knitting in fashion and beyond, because a lot of what we're talking about at the hackathon is the opportunity to explore areas beyond the traditional. And so the first thing we're going to do is just look a little bit about the background, the history of knitting and where it came from. And so knitting was first created when the first shaped piece of textile, shaped garment was developed, the sock. And so you can see the sock up in the corner. It's actually not knitted. It's using a technique called null binding, which used one needle and a strand of yarn, but it created that loop, interchanging loop that developed the first 3D shaped textile that was the start of knitting. Now you can see the Flyknit Nike shoe that came out in 2012, which has really embraced that idea of 3D thinking from the original sock, and now it's going into footwear. And the shoe, the Nike Flyknit shoe, and all the other shoe manufacturers have really created a whole new world of shoes. So whether it is in running shoes or in soccer cleats, or it is in a fancy Prada shoe, all knit design or footwear designers now have to know knitting and think about knitting as a valid approach to making footwear. So you can see some 3D knitted sweaters here. And so here, let's see. These 3D knitted sweaters, one looks like the traditional sweater that you would hand knit and kind of the start of hand knitting. And here, there are no seams. There's no traditional set and sleeve. There is, sometimes it started to, people started knitting from the neckline and knitting out rather than knitting it from the hem up. But the idea here in this hand knit sweater and the idea in this 3D knitted sweater is very similar. It is knitting in 3 tubes that are then being combined into one into one garment. And so we will, let's see if it will allow me to play this little video. Hold on. No, I don't think you can see it. Where did you go? Yep, I don't think you saw that. It showed up on the other screen for me, so I'm going to leave it. I'm going to share this presentation, and you'll be able to take a look at the video where you can kind of see how a dress is knitting in the round. We will go to the next slide. Social impact is another approach to knitting. And so you might have heard of during the war that there were a lot of calls to knit for people in the army that needed socks or needed scarves or hats to stay warm. And so that was one of the areas in which social impact and knitting is closely related. But today we can see it in a lot of different ways. We can see it through what is called knit bombing in the streets or yarn bombing. And so really when someone takes over a park bench or something like that with a knitted artwork really to make a statement. And so there are a lot of areas for social impact in the knit industry. Technical fashion. So here, if we're looking at it, you can see Coco Chanel up here, who kind of brought knitting into the fashion world. Of course, knitting existed and knitted garments were worn and used long before this. But what happened through Coco Chanel, bringing the wool jersey in as a garment that was fashionable, not just for keeping you warm, but to make a statement or be a little, stick out a little bit. She was a daring designer in that way. And so she brought that wool jersey into the field of fashion. Today, we see it in different ways. So in the Balenciaga 2014 collection, this piece was part of the collection. And this is actually a laser cut neoprene that is laser cut into the shapes of the knit stitches and then linked together. And so it's an untraditional approach to knitting, but a way to make a statement. We have a lot of knitted art. So from the historic tapestries to a knitted glass sculpture. So you can see that that's a very different approach to knitting. Actually, when they are knitting the glass, they're knitting with a wax to create a cast and then casting into it. So they're not actually putting the glass on the needles, but it is bringing a very interesting approach to the textile. We have knitting in interior design as well. And so the idea of finishing the shape to stretch onto a frame, as you can see it here, is one of the approaches to knitted interiors. And so here they are doing all of the construction during the knitting phase. So there's no stitching to be done afterwards, no piecing things together. It gives you a bit of a opportunity to save on that next stage, but it's also a very sustainable approach. And so that is why they started the fly knit shoe. One of the reasons was to eliminate that waste as they were knitting. They didn't need to cut out the material. They could also place specific features on the fabric likewise, they're using it in the interior designs, placing the important feature that you're looking for in a certain part of the material is very complex, which is something we couldn't do typically in a woven fabric. So when a fabric is woven, we would have the warp, and then we would interweave the weft threads. And so we're doing a square or long rectangle as a starting point. For knitting, we can narrow, we can widen, we can knit different things in this section compared to this section. So we have a lot of opportunity for variety there. In that respect, we can see some untraditional pieces. These are from, you can see this skateboard is from Stoll. They are the manufacturer of the machine. They're a sponsor of this event as well, but they're the manufacturer of the machine behind me. And so for industrial knitting, that is one of the big companies. And they put out every year a catalog of them pushing the envelope, looking at how they can explore and experiment. And the skateboard cover was one of their exploratory endeavors. We can also find knitting in architectural structures. So here you can see a cast. You can see the pattern on the inside is knitted, and then there's cast piece over top. So it's formwork holding the, I don't know if it's cement, but holding that cast in place. So it's knitted and then cast into. When we're looking at this structure over here, we have played with the textile and stretched it onto some other shape. Jenny Sabin down here has, this was an installation in the MoMA, kind of playing with even more with that experimental space. There are also medical applications, of course, for knitting, and it's easy to think of more circular compression pieces. There are, this is a glove, for instance, that is knitted and it completely shaped and to the hand to have the fit and the compression to enable more movement or whatever they need in this application. And so they have different kinds of structures, different tension on the yarn in different parts in order to give the best compression or the appropriate compression for that application. So just to throw you even further out of the expected loop, we can see this is an car interior piece for a car seat. So of course, inside the car, there are a lot of different textiles, and the car seat's the first we maybe think about, but there are a lot of areas inside a car that has knitted components. And so the dashboard, the ceiling, the door inside of the door, but also if you look at the car to the right, every red dot in this picture has a knitted mesh. Now this mesh is knitted on a specialized machine, of course, that can knit metals. And so you can see this little ring up here. That's knitted mesh that have been compressed into that shape. And so it's functioning in many different ways. It could be a filter, it could be a lot of different things. But it just is here to kind of open up our minds a little bit about what knitting can do. So we're coming to a close, and of this little presentation. So here we have a robotics arm, and they're using knitting in here to allow for a certain movement of this robotics arm. So once again, just thinking outside the box a little bit on what is possible. So I want to see if there are some questions that you would like to ask. If you want to put a question in the chat, that would be great. If you have any thoughts or anything you want to share, please let me know. And I would love to hear your points of view. No, you cannot work. So we have a question if you can work by yourself in the competition. And actually, this is a team-based competition. And so you're required to find someone to work with. We'll have several team building sessions or opportunities, but also don't hesitate to reach out on the Slack or go test out the networking session and see if you can find someone there. There'll be a few different opportunities for you to connect. There is a team building session right after the opening, and then some birds of a feather opportunities. So if you're thinking about doing something in knitting, we have a question on how best to get started designing for knitting-based technology. So depending on what you're looking to do, we have a couple of different options. And so first of all, what you could do is you could go to look at some of the dev posts from last year and see what they did. There were a few students who did projects with knitting. If you have some idea of what you want to do, we have a couple of mentors that can kind of walk you through the steps when you get there. But the first thing you want to do is think about why are you choosing knitting? Is it to build a special shape, or are you looking at using knitting to hold the shape in the garment? Sometimes it's used for stretch. We know that knitted garments can compress or stretch out or pull in. And so that's something that you could think about. Really think about what feature of knitting are you looking for? What do you want your garment to do? And what do you want the knitted component to do? So is it that you want the comfort of knitting, or is it that you want to have, if you go, there are some areas where you might want to have a sensor into your piece that could read something, right? That's some of the things we've seen in the past. And so maybe you need to hold that sensor against the skin for it to be able to read what you're looking for. And so there are different ways to work with that. And so through this competition, we might not be able to fully create that. But one of the things that we are doing is we will have some people working with you to do a little bit of a prototype. Maybe it's just a swatch to see what structure that you would want. And so looking at some different knit structures could be one way. I'm happy to share some kind of basics of what structure could work with what, if you have those kinds of questions. You know, if you're not experienced and don't know anything about knitting, in understanding the structures, we're happy to walk you through those steps. Did that answer your question to some degree? Great. Are there other questions? I'm going to open the dev post. I didn't realize I had to have another window open, so I just have to find it in a new window over here. There, let's see. Okay, so if you're not familiar with DevPost, it's something that you will use throughout the weekend. You can also find previous hackathons and what people have done. So I just go into DevPost, and here I'm going to share the screen and you can see what I'm doing. Share. I just Googled DevPost and got to their site. I type in fashion tech hackathon. And we can find this year's hackathon, year 17 for this. So if you haven't signed up for DevPost yet, nudge, nudge. This is a good opportunity for you to do that. Here we can see last year's event. So I'm going to click on last year's event. And here I can look at some different projects. So I'm going to go to the project gallery. And I'm just going to pull out a couple of examples of teams that used knitting. So smart filtration infused knitwear. We will click on this one. And here you can see the team that worked together. It was a different world back then where we could all be unmasked and close together. But you can see that they have developed a knit swatch here. At the time of last year's hackathon, COVID hadn't quite hit here yet, but the wildfires in Australia were going. And so they had started thinking about how bad the air was. And they'd started thinking about filtration and masks. In a way we are all thinking now almost. But they started developing a swatch and started thinking about how could the textile change, or how could the textile help with the filtration. So if you look here, they've created a pretty basic swatch. It's not necessarily a mask at this point. Developing a mask takes fitting and different components, but they've developed a swatch and they've started thinking about how they could create the filtration. And so if you look through here, you can have some ideas on what you could do. I'm going to see if I'm able to get Paul logged in. So one of our, I was supposed to have a friend with me as a moderator to help out during this session, but I am not able to get him on board. Oh, fantastic. Thank you, Margarita. Or how, all right, give me 1 second to just need to let him know. All right. Oh, great. Perfect. Paul is here. We're going to see if we can hear him. I'm going to stop sharing and see if that makes a difference. We are waiting for Paul. He is figuring things out, and that's the fun of this whole experience. In the meantime, oh, there he is. I see you, Paul. I can hear you. Can you hear?
Can you hear
us?
Me speaking?
Yes, there you are. I can't see you, but I can hear you.
Oh, great. Let me I'll work on the camera next. Give me 1 second.
Sure.
Or if you have stuff that you want to talk about, I think I can probably figure it out. And I'll just,
okay.
As soon as I get it going, I'll join you. And I'll chime in with audio as I hear you say stuff, and then once I get the camera going, then I'll just keep going with it.
Wonderful, wonderful, great. All right, so we talked a little bit about going to look at DevPost to get some ideas on what you might want to do. But what we would suggest is, if you are thinking about doing a project with knitting, start by drafting a little bit of a sketch. Write down some ideas on what you would want the fabric to do, and kind of think through some questions, because I realize there are a lot of things we can do with the textile. There are a lot of areas where we could integrate whether it's compression, whether it's a little padded area maybe you need, or of course decorative is the easier part. You could do something with a print, or well, technically it's not a print, it's a jacquard, but it looks like a print so that you have a pattern on your piece. Like we said, we will be working with you to maybe develop some samples if you're interested, but we won't be able to do a full garment because we're working with potentially a lot of students. And what would happen would be, we would photograph the piece and share the photograph with you so that you could integrate that into your presentation. Paul, would you talk to them a little bit about how you've worked with students before, and what kind of stages, or what things they should prepare before they come and talk to someone about knitting?
Yeah, absolutely. And I apologize. My camera is saying that it's unavailable. It might be a browser issue. I'm looking into that. But in the meantime, I can still talk to everyone. So hopefully you can hear me. I happen to be in a manufacturing facility right now, and I'm on. My mic is through my AirPods, and so hopefully you can hear me okay. Just let me know if you can't hear my voice. But so Linda's point. And so Linda, may I ask you real quick, what all have you presented so far? Did you do the slideshow that we?
Yes,
okay.
We just went through the kind of the background and the slide presentation that you and I looked at.
Okay. Great. So they got a high level overview of like some of the capabilities of industrial knitting. And so
yes.
To pick up on what Linda was saying, the way that you should think about how to utilize this technology is to, well, let me back up for a second. So you're working to create a prototype within a short time frame. And so you have to kind of think practically, to make things even more difficult, you're all unfamiliar with this technology. And so I think the best thing to do would be to come up with your general idea. And then if you are interested in using industrial knitting, seek out one of the mentors that has that expertise and explain your idea and let them kind of guide you through the process. And we'll be getting some information on what exactly you as participants are going to be putting together. And so we'll have an idea of how to guide you through meeting those specs, and we'll advise you as to what materials to use, what knitting techniques to use, what the feasibility of your idea is, because there are a lot of great ideas, but sometimes those great ideas just aren't executable on these machines. And so we'll kind of be like we'll guide you through the process basically. And so it's tough when you're not familiar with the technology to even know sometimes what to ask. And so that's okay. Hopefully that you got at least a bit of an overview from Linda's presentation as to the capabilities. And there's no bad questions. And so if you're not sure what can be done, just ask, and we'll be happy to tell you whether a knitting machine would be the best technology to use, or whether some other technology might be the best thing to use. And so I think at a high level, that's probably the best way to approach it. And then, I think just ask questions, and don't. There's no dumb questions at all, because you don't know this technology whatsoever. And so, just to give you a brief bit of background about myself, my background is in computer science and math. And so I, at one point, knew nothing about this technology also. And I had to come into it as a complete novice and learn everything from the ground up. And there's no shame in it. I had a lot of great people giving me a lot of great help. And so we're happy to pass that knowledge on. I've gotten to the point now where I'm running my own company that uses this technology. And so it's definitely something that you can learn and you can make use of. And so just definitely just ask questions. And for the rest of this presentation, I think we'll probably be talking a little more about some of the things they can do possibly. And so, and Linda, cut me off at any point. I was going to say one more thing about, I think one I think the approach that you can take as far as these machines for your project is to think of, or the best use of these machines is to do things that can't be done with cut and sew processes. So if you have someone with textile experience on your team, they probably have done things like gotten bolts of fabric and cut things out of it to make various patterns and things like that. So that process is actually faster than making stuff directly on this machine. But what this machine is good for is doing intricate technical things, as well as complicated fabrics that would be difficult to execute by hand. So when we've done this sort of introductory workshop in the past, we've shown examples of technical items like tubular fabrics that have no seam, because that's pretty tough to do by hand. Fabrics that have padding in it, so like they call that a spacer fabric. So tubular fabrics with padding in them, fabrics where you need specific shaping that's like kind of shaped at the edges, and it's tough to describe this without showing you visuals, and so you have to pardon us about that. But yeah, just kind of let the overriding guidance be, if it's tough to do by hand, check and see if it's possible to use the machine to do it, because that's the best use case of these flatbed machines. Is to make intricate and technical fabrics. And so I see Linda has the swatches pulled up, and so hopefully we can show some examples of what I'm talking about in terms of like technical and complicated fabrics that would be tough to do by hand. And so, Linda, do you have any swatches that you've pulled up that might be good to show people? Hey, Linda, I can't hear you. I don't know if everyone else can hear you or not.
Muted myself. Sorry.
Oh, okay. That's okay. I can hear you now.
Yeah. The standard. I know this is a colorful and maybe not so technical looking swatch, but one of the things that I wanted to show on this piece is how first of all, how something would be done in knitting. Generally, the idea would be that's the big difference between, we might have some people in this group who doesn't have experience with textiles at all. Who knows?
Definitely.
If you don't have any textile experience and you're just curious, like Paul said, please ask questions. We're here to help you, and we're hoping that you have a chance to learn. So in this textile, I'm just going to talk through it. You can see that it actually started knitting from the bottom. It knitted just a straight box. So in that respect, it's not very complex. But here, it has a pattern that goes across. You see this kind of checkered pattern. It is knitted with what's called a float back jacquard. So to just create this aesthetic, they have created a different back. But then they also have a pocket right here. You see the motif. It's closed right now, so I can't put my hand in there because that's how they knitted it. But if you look on the back, there is another layer of knitting. And so you can see that it has another function. It has the opening, a pocket that's knitted in. They didn't need to seam it. It was knitted into the piece. And so that's that is one option of something you could do, adding a pocket in that is placed specifically. So we might not necessarily knit this up as a prototype for you. Some of these we might have something that we could take a picture of and share with you and show you what's possible. And some of it might be that you're sketching it out as a design, but it's important for you to know that it is possible to knit in multiple layers in order to create this kind of a pocket. At the top, you can see another feature of kind of playing with what the machine can do. And so you have these little cords, they're loose and separate. But this is all developed on the machine in this kind of a complex pattern. And so it's just this area down here is knitted as a stripe, but it has some different sections in it. And so just an example of a couple of different things that you could do on the machine.
And to build on what Linda was just saying, so yeah, there are not only decorative, but also functional things you can do on these machines. And so from a programming perspective, somebody wrote a program that not only produces, and so just one other thing about that pattern that she was showing, in that that's not screen printed or digitally printed. That's actually the placement of each color of yarn is what causes that pattern. And so that's all done right on the machine through the placement of different colors of yarn. And so somebody wrote a computer program that not only placed each yarn where it needs to go, but then also moved the devices that are holding the yarn, which are called yarn carriers. They were moved in such a way that it also created an opening for that pocket. And that has to be done kind of simultaneously as the decorative pattern. And so somebody programmed all that stuff into a computer program that then is run on a machine that's similar to the one that's in back of Linda right now. And so that's kind of a very high level summary of what happens and how you get those instructions to make that swatch. And so Linda has some more examples here that we're going to show you. So you're seeing that these kind of complicated things that would be very tough to do by hand, you can program the machine to do it. So Linda, you have it looks like a gourd example?
Yes, a gourd example. So if you know hand knitting, some of you might know hand knitting, this would be called short rowing. So when the machine knits, creates a row of loops, and then it comes back over and connects through those loops, right? When you knit by hand, you have 2 needles. When you knit on a machine, every stitch has its own needle. So, but the idea is the same. The yarn goes across, and when you short row, or gore, as this could also be called, you turn around before you get to the end. So you can imagine I'm knitting this way. If I'm knitting up here, I'm knitting this way. Then I turn around. You can see this white section. It only knits on this side. So it's knitted as a stripe. This piece is knitted as a stripe, but they've stopped knitting before they got to the end. They've knitted the short row. And so that gives us an opportunity to make the fabric longer on the one edge compared to the other edge. So it gives shaping in a different approach. If you've seen some of the knitted masks that are out there currently, this is how a lot of them have been developed.
It's a very powerful technique for shaping. So yeah, another category of things you can do on the machine is shape fabrics. And so I'm glad we have some examples to show, because it's very tough to just describe it out of thin air. But yeah, you can use that technique to shape, create curvatures, bubbles, triangles, and so forth. And so, yeah, Linda mentioned things like masks, but even things like shoe uppers also. You'll see, and actually the classic example of short row knitting, also known as goring, the classic example is socks. If you ever look at a pair of socks, the heel is almost always done through this technique. And so if you ever look on one of your pair of socks, you can see a sort of a line that looks like it looks like a sewn line, but if you look really closely, there's no actual sewing right there. It's just where the stitches are being held as one side is expanded. And so, like, next time you have a pair of socks, look at the heel, and you'll see kind of like that line indicating where they hold certain stitches in place, knit the heel, and then continue knitting the tubular part of the sock. So yeah, that was a great example.
Great. So, so what Paul was saying, there are different ways to shape. So here we can see that we've knitted one side and another side, and not quite sure what this was supposed to be, in all honesty. If this is because it has, well, because it looks like a neckline over here, but then maybe it goes around and this is the back. I'm not quite sure. But
yeah, that's an interesting one.
But you can see that it's been shaped to be a garment. Here's another piece where you can see kind of possibly the front edge here, and up. This would be the neckline. So that's a different kind of shaping where you're shaping it on the side. And so there are different shaping approaches, but goring gives the more, if you're working with fashion normally, if you have a dart normally, you would use the goring technique to develop that kind of a dart shape.
It's a little more fluid. And so the thing to point out about all these shaping techniques is that it doesn't involve cutting or sewing. So there's no damaging of the fabric at all. You're just creating the shape by the placement of stitches or the reduction of stitches. And so, yeah, there's just another technique that can be done on the machine, and it's done right through made.
So here we can see another more shaped piece. And so you have this outline of the pattern or the piece knitted in shape, but it also has these kind of fold over features. So once again, it's knitting these as layers on top of each other to create. Here, it's for aesthetic value, but for a more technical application, you might need more layers to hold different things, where some things should touch the skin and some things should not touch the skin, or something is holding or is encasing something for you where it needs to be away from the body. And so kind of thinking through the reasons for some of what you're doing.
Yeah, absolutely. And to build on something you just said about placement of yarns, there may be cases where you need to have an abrasive yarn on one side, but you don't want the other side to be abrasive. And so there's a technique called plating that you can use to position the yarns in such a way that one yarn remains on one side of the fabric and another yarn remains on the other side of the fabric. So that's not quite what Linda was showing in the visual, but that's something that she sort of alluded to in what she was talking about in terms of yarn placement. And so not sure if we have any plated examples over there, but I think, Linda, you have something to show us again now?
Yeah, so this is because you mentioned plating, I had to get a example out. So you can see that this is a very thin fabric, right? You can pretty much see me through it, I think. And so this is knitted with two, you see that it has two colors. Here, the two yarns have knitted together in every stitch, just like Paul was saying, it's been plating. And so that means where you see the one color, the other color shows up on the back. Mm-hmm. And so in every stitch, they're knitting together. And so it looks, it's hard to see it when you can't kind of turn it around and look at it yourself, but you can see that it looks almost the same on the front and back, just reversing the colors.
Absolutely. And so plating can be used not only, as Linda's saying, for placement of color, but also for functional use. And so a real life project I once worked on, they wanted to have a metallic yarn on the front to have like a shimmery sweater, but then they wanted the other side to be soft against the skin. And so they used, I think it was cotton on the other side, and then had some kind of metallic yarn on the front. And then through this plating technique, they knit And so the machine will automatically arrange the metallic yarn to be on one side and the soft yarn to be on the other side, so that when it's put into a garment, only the soft side touches the body.
So another example of what the machine can do. So depending on what machine you have different, Paul talked a little bit about yarn feeders. You have a different number of yarn feeders. This is knitted on an ADF machine because it has a tremendous amount of different yarns in here. So each of these different colors would need to be brought in by a different yarn feeder. But you can see that simultaneously it can knit a lot of different strands, and they don't have to connect if you don't want to. Down here, you can see that they are connecting, and up here, you can see that they are separate from each other. And so, so that is another kind of approach to thinking. I know when you're thinking through some of conductivity or something that can touch another area, that's something that you could think about. How do you place it? What's next to it? And or how do you play with different colors? Some machines can do this. Not all industrial knitting machines can do this, but that's it takes a long time to set this up. But it might be something that would be interesting for you to think about as an approach as well.
Absolutely, and to kind of generalize that, that technique is called intarsia. And to generalize intarsia, so that was a very specific example of it, but you can also use intarsia for functional reasons, like say that, so in general, intarsia is the act of using multiple yarns across the width of a piece without them overlapping. And so for each zone, or what they call an intarsia field, you need a cone of yarn. And so for that piece, you need probably over a dozen cones of yarn. You need one for every single color across the row. But in addition to decorative things like colors, you can also use this intarsia technique to knit different zones across the width of your piece for functional reasons. And so an example of that is knitted masks, like COVID masks, where you have one zone that's doing the face covering part, and then you have two other zones, one on each side, doing the ear loops. And so you can make an entire mask using this technique without ever having to cut and sew anything, because you just use different yarn carriers to do the face covering part and then the two ear loops respectively.
So just to kind of give you a simplified version of what Paul was saying of intarsia, it means that the front and the back have the same color. So where one yarn is knitting, maybe you have multiple yarns knitting together, but they don't carry across the whole width. They only have their own section or segment where they're knitting. So here you can see that this color knits only here, then over here. This is actually another yarn carrier in order to be able to knit there, because it doesn't travel across. Then we have another yarn carrier here and another one over here. So you can see how the front and back is the same. If we look at a jacquard pattern, which is another way to do kind of a printed pattern or a print look on a knit, you can see that the front and the back are opposite of each other here. So it's both yarns continue across the whole width to make the fabric. On the other piece, the white would only knit in a certain section and the blue would knit in a different section. Here, the white, when it doesn't knit on the front, it knits on the back.
Absolutely. And Linda, if for that intarsia piece, that simple intarsia, yeah, right there. If you were to put this into a technical context, let's say, for example, that the white stripe across the middle was an area where you needed conductivity or something like that. So you could have a conductive yarn knit only in the middle, and then have other yarns surrounding it that only knit in their respective zones. And you can isolate each section like that in the programming if you needed to have some functionality like that. So you can kind of use these, even though we're showing specific examples, you can kind of extrapolate from that and kind of think you can take the basic techniques from it and sort of apply it to other contexts. And so that's obviously easier said than done. But as I said before, if any of these look interesting to you, definitely ask questions about it, and we can tell you whether what you're thinking of can be executed in the way you're thinking. So definitely just ask questions.
Some of this is a little difficult to show you on a screen, and I hope you can see. But here you can see. So this is using different thickness of both yarn and size of stitches. So in this sample, they have knitted this portion on every needle and this portion over here on every other needle. So that gives you an opportunity mostly for aesthetic purposes, but sometimes it's a technical reason too why you would need to knit on every other needle. But here you can see on one machine, you can get different looks. Whether you want it really chunky or very thin. This is a little tricky to do if you're not, you might have to ply up a lot of ends of yarn in order to be able to get it this thick, and your machine needle needs to be able to handle that. Whereas here it is knitting a finer yarn and on every needle. So that's another kind of thing to play with.
Absolutely. And it would, definitely involve a lot of trial and error in getting the proportions right for it to come out looking right.
Yes, absolutely. And actually, this is knitted on a 3.5.2, I think. 2.5.2. We don't have this gauge machine, but the general gist of doing two slightly different sizes is possible, but you can't get so extreme. It depends on what machine you have to work with.
Yeah,
I wanted to show this example where you can see super thin in some sections, and then some sections that are double layered. So kind of like we were talking about how you might want to encase something in certain areas and you want something to be really light or thin. That's an option. So you can have closed or covered sections and more open sections and plan it out. So this is kind of an intarsia. Hold on. It's knitting with Goring, actually, to create this piece. So we're almost out of time. I want to check and see what kind of questions there are. If there's anyone who has any questions, we really would love for you to reach out and talk more to us through the Slack channel. And we're happy to come meet with you in your teams and talk more about what's possible. So any questions?
And as Linda says, if you don't have the questions now, you can definitely seek us out later through any of the various channels. Of course, when you get with your teams and you think about your concept, that may bring up questions. And so, definitely there's no dumb questions. Definitely feel free to ask anything, and we'll be happy to guide you through your thought process and let you know the capabilities of this technology. There's a lot to take in when it comes to this technology. People spend a lifetime trying to master it, and so you're definitely not going to, learn it all in an hour and then just be able to just jump ahead and do it. And so definitely don't feel it's probably overwhelming to get all that information. And so definitely don't feel bad about it. We'll be happy to help explain things as we go through the weekend.
Great. Well, thank you everyone for coming. I want to make sure that you have that you get to the main stage session for our opening ceremony that's starting at 5 o'clock, which is in 4 minutes. And so thank you for coming. If you have any more questions, reach out. And we look forward to seeing you through the hackathon.
Okay, thanks, Linda.
Thank you.